Hey, Mr. Harridan here. Go Rangers, just so you know. I'm going to talk about the dissociation of acids and bases. As a reminder, acids and bases dissociate just like ionic compounds do because they are soluble in water. Okay? So, strong acids and bases completely dissociate in water. 100%. Okay? They form a one-way arrow when you do the reaction. Okay? Since they have lots of ions of H pluses and OH minuses, and they dissociate 100%, that is what makes them strong. As opposed to weak acids and bases, these partially dissociate, which means that these are in equilibrium. So we need to use the forward and backward arrows for weak acids and weak bases. Okay? These do not have 100% H plus and OH minus in it. Usually it's less than 10%. Okay? And these are usually closer to neutral. So pHs are closer to 7. Okay. Okay. How do you know if something's strong acid or strong base? You have the strong acid list. HI, HBr, HCl, HNO3, H2SO4, and HClO4. Those are the 6 strong acids. Okay. Strong bases, those are group 1 and group 2 hydroxides. Okay. So that would include lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, francium hydroxide. Okay. And then we need some group 2 ones. We don't do Be and Mg. Those are weak. And then you're going to do some calcium hydroxides, some strontium hydroxides, some barium hydroxides, and some radium hydroxides. Sure. Okay. Those are the strong acids and strong bases. Strong bases are all these hydroxides right there that I've listed. Group 1 and group 2 hydroxides except for Be and Mg. All other acids, remember most acids start with H plus. Bases, they have OH minus, but there's some weird amine ones as well, some NH3 things, NH things. Yeah. NH2 and NH3, depending on what it is. So that's the deal there. Okay. Strong acids and bases are good conductors of electricity, meaning they are strong electrolytes. Weak acids and bases are poor conductors of electricity, meaning they are weak electrolytes. Strong acids dissociate 100%. That's what makes them strong conductors of electricity, because you have lots of H pluses in there to conduct electricity, while weak acids partially dissociate, so they are weak. Okay, so here we go. We are going to do our dissociation equations here. Okay, remember, acids produce H plus, according to Arrhenius. HClO4 is a strong acid. So HClO4 aqueous is going to dissociate. We're going to use a one-way arrow for this one because it's a strong acid. It is going to dissociate into H plus and ClO4 minus, both of which are aqueous because all ions are aqueous. Okay, the next one I'm going to do here is HMnO4. This is a weak acid. Remember, acids produce H plus here, so we're going to do HMnO4, which is going to be aqueous. We are going to have a forward arrow and a backwards arrow. So this is going to produce H plus and MnO4 minus. acetic acid, not on the strong acid list, right? So this is a weak acid. Remember, we're going to take the H away from the front here. We never take away from the C. So this is going to be in equilibrium because it's weak. So this is going to be H plus, which is aqueous, and C2H3O2 minus, which is also aqueous. Okay, bases. Remember, Arrhenius said bases produce OH minus. Okay. Barium hydroxide is a strong base. Okay. So we are going to take BaOH2, which is aqueous. We are going to have a one-way arrow because it's strong. It is going to produce barium ion, which is aqueous, and 2 hydroxide ions, which are aqueous. Okay. Okay, here we go. Now we get to the tricky ones. Aniline. This is a weak base. I see the NH2 in it. That tells me it is a weak base. Okay. The problem is we're supposed to produce OH minus. So we're going to start off with C6H5 NH2. Okay. I'm going to make that aqueous. Okay. The trick to this, doing this here, there is no OH minus to produce. So this is why we have to have water in these weak base reactions. So you need aniline with water. Because that way you are going to produce the OH minus, which is aqueous. Okay. And we are going to have C6H5NH3 plus. Because we take the OH minus from the water, that means the H plus joins with the aniline. So that's going to be aqueous there. We have to do the same thing here with triethylamine. Amines are sneaky bases there. So we're going to do this with water. This is a weak base. So this is going to be CH3,3N plus H2O. We are going to get OH minus. Oh my goodness, Mr. Harridan, you almost committed the biggest mistake in your life right there. In a second here. Fix it in a second, Mr. Harridan. Okay. So the H plus is going to join over here. You can't add it to the C part, so this is going to be CH3,3NH plus, which is aqueous. Okay. Because remember, water is HOH, which separates into H plus and OH minus, so the H plus is joining up with the original thing. Now, my astute students here, if you're paying attention, you will notice the one mistake Mr. Harridan made here, doing those two. This is a weak base, and this is a weak base. So my arrows are supposed to go forwards and backwards because this is in equilibrium, because it partially dissociates. Good thing you caught that, Mr. Harridan. Good job. Give yourself a pat on the back. Okay. You guys are champions. The legend is